Here is the brief information about today's webinar. Importance of data security, security triad, AAA, data encryption at rest, TLS and SSL, client-side field level encryption, corable encryption, and MongoDB security recommendations. Importance of data security. How many of you agree if I said 40% of data MongoDB instances are running without having proper security measures? In 2020 year, 22K MongoDB instances are attacked by the ransomware attack. Based on technical expert statistics, on the first quarter of 2021, 300K MongoDB instances are running without security, and the count is still increasing. In the first quarter of 2022, 12% of MongoDB instances are peaked in the list. In generally, security-less IoT will simply treated as the Internet of Threats. In my opinion, privacy is not a right, it's an absolute necessity. In this technological world, data is the most costly asset. We are the only responsible for protecting our data from the illegal access and data corruption. Here is the data security triad. It is the chief guest when we are talking about the data security. We never skip this part. It consisting of the confidentiality, integrity, and availability. Let's see the beauty of the MongoDB, how the MongoDB security satisfies the data security triad concepts. AAA architecture, authentication, authorization, and auditing. Authentication is verifies the user. It will able to provide access to the valid user, which satisfies the concept of confidentiality in the CIA triad. And the authorization, which limits the user to perform illegal activities on the database, which maintains the integrity of the database. And then availability. MongoDB follows CA algorithm in CA concept in the CAP theorem, consistency and availability. MongoDB always available for valid users. Then auditing. Auditing is a log which stores all the activities of the user. Let's see briefly about each one in further slides. Authentication. It is the method of protecting our system from the illegal access. It is simply termed as locking the door with a proper keys. How your mobile phone having different types of locking security mechanisms, in the same way MongoDB having different kind of security authentication mechanism. SCRAM mechanism, which is default for all MongoDB instance, and X.509 certificate based authentication mechanism, LDAP authentication mechanism, and Kerberos authentication mechanism. In further slides, we will see one by one. Let's see, enable authentication in MongoDB. By default, MongoDB allows SCRAM authentication mechanism. These are the few steps. Start MongoDB without authentication option. By default, config file authentication option is disabled. And connect to the Mongo using the Mongo shell. We need to create one user with the root access. Then exit from the Mongo shell, restart the MongoDB by changing the config file by adding the authentication options. These are the methods to authenticate the user. First two are the authentication while connecting to the Mongo shell from the command line. This is the URI string method, and this is the URI with flags. And this is db.auth command used to connect to the authenticate the user inside the Mongo. I prefer db.auth authenticate method, because the user who is having the eligibility to see the history of the previous commands from the host mission, then he theft the username credentials of the user. But by using this db.auth function, we couldn't get the history of the commands. Validations. These are the steps to validate when authentication is failed. First, validate the username, password, and authentication DB. Later, verify the port number. Then check the method of authentication mechanism. Authentication with X.509 mechanism. It is fully certificate-based authentication mechanism. It keeps a full stop for the traditional credentials-based authentication mechanism. It provides both internal and external. Internal for replica set. X.509 certificate is need a SSL or TSL connection. Here the marvelous feature is $external DB is the supreme of the X.509 method of authentication method. It stores the user credentials. The username is the client certificate subject name. These are the few configuration steps involved in enabling X.509 certificate-based authentication mechanism. Create a root certificate authority file in PM format. Later, create client certificates. Edit the config file with these options. Then we need to create a user with the subject of the client certificate. We can get that subject by using this openSSL command. This is a sample URI to connect to the Mongo when we are enabling the X.509 certificate mechanism. These are the flags related to TLS connection. Let's see how the integrity is achieved in MongoDB. Authorization. It restricts the user to perform different kind of actions on particular resources with given privileges. Role-based access control mechanism provides the authorization which maintains the integrity of the database. It improves the efficiency of our MongoDB system. Why role-based access control is needed? Various users log into our database and perform different kind of actions. In such cases, providing root access for all users is not a proper solution, and it is not recommendable also. Users may do writes, reads based on their necessity. Some users may write some data, or some users may remove some data. That may happen human errors, and which cause data loss and illegal access of someone's private data. Roles in MongoDB. Role is a detailed object which is having the actions and resources. Actions are the events performed by the user, and the resources are the at where the user is going to perform the activities. Those are in the MongoDB level. Resources are the DB and collection. Built-in roles in MongoDB. In our daily life, from a farmer labor to a founder of multinational companies, how different people are playing different kind of roles in their respective occupations. In the same way, MongoDB provides built-in roles in MongoDB. Those are all the names itself indicates: read, write, root, DB admin, user admin, DB owner, and various etc. roles are present. The beauty of MongoDB provides the customized roles based on the requirement of the user administrator. to perform specific tasks for the particular users. A demo for authentication and authorization. These are the few steps involved in enabling authentication in MongoDB. Here I am going with Scram authentication mechanism. First, configure with restart the MongoDB without enabling a security option. Create a user with root privileges. I am entering a random data on the database for testing purpose. After creating the user, enable the authentication option in MongoDB. Later restart the MongoDB. There are two types of methods are there to authenticate the MongoDB, as I said previously. After connecting to MongoDB, we can using db.auth function. While connecting to the MongoDB, we can use the command line with the command line flags. Let's see the one of the most interesting feature in the MongoDB. Again, I am sharing the PPT slide. I hope the screen is visible now. Key file authentication mechanism. It is an internal authentication mechanism. How an organization maintains the uniform between the members to recognize them. In the same way, a key is shared between each member in the replica set. To use this key file authentication, we need to create one user in the admin database. These are the few steps to configure key file authentication. We need to create a key file with openSSL command, which consisting of 6 to 1024 characters. We are providing a root privileges only. Copy the key file in each replica set member and modify the config file by adding the security.key file option in the config file, then restart the MongoDB process. Okay. We have locked our system, but we need some more betterment in the security. That is, we would like to monitor how users are performing on the DB side. Yes, you are hearing the right. MongoDB having a CC camera feature like auditing. Auditing is the most interesting concept in the MongoDB, which tracks the system activities and users authentication and authorization activities, CUD operations and replica set and sharded clusters details. We need to review the data in the regular time intervals. Then it will more advantages and it will add accountability and easy to investigate any suspicious activities is happened, and it allows user to monitor the DBC. Configuration steps involved in auditing. It is in YAML format. MongoDB by default having the YAML format config file only. These features are included in MongoDB Enterprises and Aptos versions. And compression mode, by default it is none. If we want to enable compression, then ZSTD is the method of compression. Destination file syslog console. Here we need to talk about the syslog. In Linux, CentOS flavor /varlog is the /varlog syslog is the destination file, and for Ubuntu hosting missions, /varlog messages is the destination file, and the format is the type of storage, JSON structure or BSON structure. If you are using the BSON format, then you can use it to BSON dump command to see the data. And path. Path is the file destination. If you mention the destination as the file, then you need to specify the file path. Filter. Instead of taking all collecting the all user activities, we can limit them with this filter option. It uses query selectors like in operator, less than or equal to operator, greater than operator, like that. And it allows the regular expressions also. It helps in a lot of places. Syntax, filter, field, and expression. Filter, field is the key in the data, in the structure of the audit message. This is the simple filter command to collect the CRUD operations. When you are giving the CRUD operation, then you need to provide the audit authorization success true message in the config file. This is the audit message structure. This is in JSON format. It consisting of the fields, A type, which specifies the action type, timestamp, UUID, local, remote, users. It collects the user which logged into the mission and roles those for the respective users it will collect, and param based on the operations which is performed by the user. This param field will change. If the user is doing read operations, then it will first collect the command, whether he done read or write command, find or count, and then it will collect the namespace. Later it collects the arguments. Arguments means if the user having any filter, that one, and skip, limit, those kind of information is collected in the param, and result. If the event is successful, then a 0 value is assigned to the result field. If the event is failed, a natural number will assign it to the result field. Versions versus features. The auditing feature is available after 2.6 version. As I said previously, MongoDB Enterprises and Atlas only having this feature. After 3.0 version onwards, filter is provided. Yes, 5.0 onwards, runtime configuration and filter management while MongoDB is running, no need of downtime. UUID is added for audit message after 5.0 only. In the config file, compression mode is added at 5.0. It is a minor version. This encryption is added in 6.0 version onwards. Achieving MongoDB features with the community. As I said previously, MongoDB, this feature is available in enterprise version and Atlas version, but Percona MongoDB provides this feature in the community version itself without no cost. The only difference is UUID is not added in the Percona MongoDB server auditing message structure. Let's see the configuration steps and how it will perform with a demo. And now the screen is running. These are the few configuration steps involved in auditing structure, auditing concept in the MongoDB security. Edit the config file with the auditing options. This is a pre-recorded video on MongoDB Percona MongoDB server 4.0 version. After adding the config file parameters, then we need to restart the Mongo. I am doing some random operations on the DB side. I created a database and I created a collection, and I am reading the I am reading the file inserted collection. This is the structure on the destination file. Here is the audit message. Consider this at the last. I read the data, right? That data is added in this one. I run a find command. on MyDB new collection. The name of the command is added at here, fine. And I run without any filter. The operation is resulted 0. That means the operation is successful. Again, we move with the slideshow. Yes. Now you locked your system and added a CC camera security. But there are some theft in market. They hide their information and break your locking system. To get rid of this problem, is there any solution in MongoDB? Yes, absolutely. There is a solution in MongoDB. That is data encryption. An encryption mechanism protects the data and it hides the plain text and convert it into a ciphertext. Users who really authorized, they only can understand and read in the readable format. MongoDB involves 3 types of data, that is data at rest, data in transit, and data in use. The base of encryption. Encryption is the subpart of the cryptography. Cryptography is the study of science of the secret communication in the language of mathematical algorithms. Cryptography is word come from the Greek word. Crypto means secret and graphy means right. Adding the cryptographic technology in the database science is the one of the landmark in the history of database security. These are the few terms which is used in the encryption concept: plain text, key, ciphertext, cryptanalysis. Ciphertext is the value which is encrypted by the key of the plain text. Let's see data encryption at rest. MongoDB by default, White Tiger storage engine allows this cipher algorithm here by default is AES 256 GCM algorithm, but it is not supported with the Linux. For Windows systems, CBC algorithm is used. It involves symmetric key. That means both encryption and decryption process will take with only single key. Options: we can store the master key in 2 places, that is key management services, or we can keep it in our local system, but it is not recommendable for production cases. We can use different keys for each member in the replica set. That is a recommendable option to protect more in the database level. Configuration steps involved in data encryption at rest on community. Actually, it is available in Percona Mongo with free of cost. These are the configuration steps. Create a key file with the base 64 and 16 to 32 characters. Edit the config file with these enable encryption options. Then restart the MongoDB. The only way to validate the data encryption at rest is by grepping the encryption word in the MongoDB log file. Then we can get the message like encryption keys DB is initiated successfully, then it is successfully running. Okay, now the data is safe at rest. What about the safety while it is in transit? Data is traversed through the SSL and TSL. There are few certificates are involved. PM file, which are self-assigned certificates issued by the certificate authority. These are the steps involved in configuring TLS or SSL connection. create a certificate authority root file, then create a client certificate key file, later edit the config file with these TLS options, then restart the MongoDB. This is the flag. This is the MongoDB URI flag structure. These are the flags used to authenticate from command line. We need to specify -- host flag even though you are connecting from local host. A sample demo to implement transist encryption with Percona MongoDB process. Now it is running. These are the few steps involved in creating. First, we need to generate the key files. First one is the root file. While creating this root file, we are getting a console. We need to fill with relevant data, or we can specify the random data while generating the subject of the root file. After creating the root file, we are going to create the client certificate file. In this one also we get a console. In that console, while creating the common name, we need to mention the host IP of host name of the MongoDB server on which it is running. Later we are changing the file permissions. Restart the MongoDB after adding the config file parameters. This is the command line authentication URI. I installed in port 27019. We need to create user in $external DB with the subject of the client certificate. To authenticate MongoDB, we can instead of authentication database name, we need to specify as the $external DB. MongoDB always allows the users with by default authentication mechanism, which is SCRAM. Even though you are mentioned the X.509 authentication mechanism in config file, it will allow user to authenticate to the DB with the SCRAM mechanism. Let's move with the next concept. Okay, good. Now the data is safe at transist, but what about the safety while it is using? There is a concept which always making the MongoDB in the top place of the list in the NoSQL database, that is the client-side field level encryption. It adds the feature that we can selectively encrypt the individual documents. It is a fully end-to-end encryption. By using a key, we can encrypt the field with specified algorithms. For example, we take a doctor's prescription, which is understandable by the doctor and the pharmaceutical guy, which is present in the medical store. But it is not understandable by the user. If the patient is understand the name of the medicine, he again went to reach the doctor for the same problem, he directly go to the medical store and purchase that medicine. For the business cases, they hide some information. For publicity things, they reveal some information. No offense, just for kidding. Why client-side field level encryption is important? In-flight encryption, that means data encryption in transit, it will protect the data while it is in traversing. But there is no assurance for the data in memory and rest. The person who can able to access the host machine, he can able to see the data then it may cause data breaches. At rest encryption will protect the data in stored format, but there is no guarantee for the data protection which is in memory or in flight. The client-side field level encryption will provide a security for the most sensitive data, which never reveals the data in whole data life in the DB level, in DB level and application level. Here are two types of keys involved in client-side field level encryption. One is customer master key and second one is data encryption key. Customer master key, which is generated by the user, it is the root key that is stored in the KMS, or we can maintain it in local also, but it is not recommendable way. And the data encryption key, which is created by the library MongoCrypt, and that is encrypted with the customer master key. This data encryption key is only involved to encrypt and decrypt process with the driver. This strategy is based on the envelope encryption. This will be treated as when the data is encrypted with data encryption key. That encryption key is encrypted with the customer master key. Let's see the process how the field level encryption is happening in the MongoDB level. A user is querying something from the database, then a driver is involved at here. It validates the query. If the query is having any field which is encrypted with the client-side field level encryption, then the driver fetch the data encryption key from KMS, then that data encryption, the driver will go to the database and search the relevant data which is in encrypted form only. Then it collects the encrypted data, and after collecting the data, it do the decryption process and provides the user in the readable plain text format. Availability of client-side field level encryption. It is available after 4.2 version. 20 plus platforms in multiple languages drivers are supported. Automatic encryption and manual encryptions are available. Automatic encryption is available for only enterprise and Atlas version. Manual encryption is also provided in community versions. The main difference is schema design. When you are, once you design the schema with the automatic encryption, then no need to again, while you are inserting the data, no need to provide all kind of information in the encrypt function. But in manual encryption, we need to provide for every time while you are inserting data, you need to encrypt that particular field with this particular algorithm and different kind of data encryption keys. There are few steps involved in configuring. Create a key file which is customer master key. Assign that key file customer master key value to the local variable inside the Mongo. Then frame the client-side field level encryption options. Because this is a community version, here the manual encryption only available. Connect to the Mongo shell with the options and then create a data encryption keys and insert some data with the encrypt function. Let's see a demo with the client-side field level encryption in MongoDB server, community server. These are the few configuration steps involved in enabling client-side field level encryption. This is I am doing on MongoDB 5.0. We need to start the MongoDB. Then we need to create customer master key without white spaces. We are providing read permissions. Assign the customer master key value to the local file, and we are configuring the client-side field level encryption options. Later, we are creating the data wallet which consisting of the namespace where the data encryption key needs to be stored, and then connect to the Mongo with those options. Later, we are creating the data encryption key with this create key command. Then a UUID is generated. After creating the data encryption key, we can able to see the data in the data encryption key wallet collection. One document will be inserted. Later, we are inserting the data. We are inserting some random data for testing purpose. A user without having the data encryption key and customer master key, then the data is shown in the encrypted form. To read that particular data, we need to have the data encryption key and customer master key. The same steps need to be followed except creation of data encryption key. To query anything in the database, it is not possible from the client-side field level encryption. For that, such cases, we need to add an if-else condition in this extension of the query. Then only you are able to see the data. Let's see the next concept in the data encryption part. Before we see this limitation of the client-side field level encryption that encrypts the query is not possible. But in the next feature, even though the data is having less cardinality, we can get that data by running some queries by using the queryable encryption. It allows user to set the data which is in always encrypted form, but it is a public preview feature. In recently 6.0 version onwards, this feature is available. It is not recommendable for production because it is in public preview feature only. These are the magical features involved with the queryable encryption. It is a fully randomized encryption. We can run expensive queries. It is a client-side. It is having the features of client-side field level encryption. The scope of necessity for queryable encryption. The data nowadays is more crucial, and privacy data is also involved in the databases. For example, bank applications, stock brokerage firms, hospitals, human resources, government applications, and e-commerce applications, etc. In these applications, the data is more sensitive data is present. Protection of that sensitive data is also very complicated thing nowadays. To avoid that situations, we can use the queryable encryption. Queryable encryption having 4 data structures, 3 metadata collections. Those are all simply referred as when you are inserting a data with the queryable encryption collection, then 3 metadata collections are created. That is ESC collection, ECC collection, and ECOC collection. These are the extensions of those collections. We can simply refer with those extensions only. A field in every document which is encrypted, that is treated as the safe content. It is a recommendation never and ever change any modifications in the metadata collections. If the data is corrupted in the metadata collections, then no user cannot achieve the encrypted data which is in plain text. Let's see how the write operations perform on the metadata collections. When we are writing a document in one collections, which consisting of one field, then one insert will be happen on ECC collection and ECOC collection. But if the collection having 2 indexed fields, then the stats will be multiplied with 2, and the update and delete operations also performed on the metadata collection with the respective figures which I mentioned in this table. Storage level issues with queryable encryption. We can expect 2 to 3 times of the extra storage requirement, because when you are writing some data on a collection, it associated to update in the metadata collections also, and which is fully depend on the number of indexes exist in the document collection. Data and index compaction. Whenever the ECOC collection exceeds 1 GB size, then we run the compact structured encryption data command function, then it prawns the metadata collections. Let's see the availability of queryable encryption. From version 6.0 onwards, it is available as I stated previously. Drivers 20 plus platforms of multiple languages, it is available. It likewise client-side field level encryption, it will also allow automatic encryption and manual encryption, but manual encryption is available for community versions. The limitations of queryable encryption. It is a fully randomized encryption. Deterministic encryption is not possible. Client manually, we need to create the manually unique data encryption key for each field. Index compaction also need to be run manually only. Automatic index compaction is not available. Standalone deployment, it is not supported. It is supported for replica set only. In the replica set also, secondary reads are not supported. That means all the operations on queryable encryption collection performed on the primary side only. Client-side field level names are immutable. We can't change the names after encrypting the field. It ignores collations, unique index and TTL index because it is a fully randomized encryption. It won't support views, TTL, time series collection and capped collections. We can't encrypt the underscore field because it is auto-generated with MongoDB. Encryption performance in MongoDB. We can expect some latency. Here the data size is directly proportional to the latency. When considering the high load conditions, write operations will get 10% to 20% latency, and reads are less than 5% latency, which is negligible. But these statistics are for default purpose, but based on the organization's data, it may vary with more percentage. Encrypting and decrypting requires more resources. White Tiger storage engine is most suitable for the queryable encryption because page level encryption will happen and throughput operations will perform on the particular pages only. It adds the high performance, scalability and security for the MongoDB. Some special recommendations for MongoDB security. Don't directly expose the DB to the internet. Never use the default ports. By default, MongoDB uses 27017 port. Use strong passwords instead. Even though remembering is problem, we need to use the strong passwords. Authenticate the DB with db.auth function. Never use the security.transaction to auth option in the config file. It simply treated as the locking the door without closing it. Limit the user actions by providing the access control mechanism. Maintain the data encryption at rest, at transit and in use. If you have any queries, we are here to answer.